All right, so we're going to look at some sequences here and determine if they converge or diverge. So the first one we're going to look at is this one right here. And for a sequence, it just converges if the last, quote unquote, the last term, the one way on the end, turns out to be a constant number. If it's not, if it goes to infinity, say, it would diverge. So these are limit questions, basically. So the limit here, I have to, here we go. The limit here, as n goes to infinity, of a sub n, we're looking at this one. Well, you can sort of think of this as the top and bottom are same degrees to the 1/3 and to the 1/3. This limit is going to be 1. That means you're just taking the ratio of leading coefficients. So that's maybe not the best way to do it, but it works. You could just I guess, the more formal ways to divide everything by n to the 1/3. So like this. So that's the top. The bottom, both terms divided by n to the 1/3 will get you this. So I'm just dividing top and bottom by the same thing. And we'll have 1 over 1 plus 1 over n to the 1/3. So now when we take the limit as n goes to infinity, this is an easy one. That's going to go to infinity. So 1 divided by infinity, it's going to pretty much be 0 here. So this limit is 1, just like we thought it was going to be. So this sequence converges to 1. That's it. So we're going to do the other two similar ways. This next one, we have two exponential functions, but they're raised to the same power. So think of it like this. So we have the limit as n goes to infinity of e over 4 to the n. So it's an exponential function. Exponential functions will either increase without bound, or if the base is less than 1, which it is, it will be decay. In other words, it will go to 0. So you can kind of, from what you know about exponential functions, you can see since e is about 2.7, e over 4 is going to be less than 1. So this is going to go to 0. Another way to think about it is just think of e as 2. So we have 1/2 to the n. And just think about what happens when you multiply 1/2 by itself over and over and over again. 1/2 squared is 1/4. 1/2 cubed is 1/8. 1/2 to the 4th is 1 over 16. You can see that's getting closer and closer to 0. So this is 0. And thus the series or sequence converges to 0. That's it. The last one has factorials involved. So what we're going to do is we're going to simplify the factorials. So this is 1 times 2 times 3 times 4 times 5, the bottom, until you get to n. This is 1 times 2 times 3 times 4 times 5, etc., until you get to 2 before n. So you can think of it like this. Eventually here you're going to get the second to last term will be 2 before n, and then the second to last term is n minus 1, and then the last term is n. So that's the bottom. You can see that all this stuff is going to cancel with this whole n minus 2 factorial, and the result would be 1 over n minus 1 times n, which is a rational function. So the degree of the bottom is 2, the degree of the top is 0, so this is going to go to 0. So just like the one before, this is a convergent sequence, and it converges to 0. So determining if limits or sequences, converge or diverge is as simple as taking limits. And that's it for that.